For example 3, we have a problem from chapter 12 in the textbook that goes over one of the colligative properties of non-electrolyte solutions. The problem asks us to calculate the vapor pressure of a solution made by dissolving 218 grams of glucose in 460 milliliters of water at 30 degrees Celsius. It also asks us what is the vapor pressure lowering, assuming that the density of the solvent is 1 gram per mole. So all we need to solve this problem is Rayleigh's law, which states that the vapor pressure of a solvent over solution, which is this P1, is given by the vapor pressure of the pure solvent, which is given this P1 to the 0, times the mole fraction of the solvent in the solution. And the mole fraction of the solvent can be expressed as N1 divided by the sum of N1 plus N2. Now, what we need to know that's not stated explicitly in this problem is that the vapor pressure of pure water at 30 degrees Celsius is 31.82 millimeters of mercury. So to begin, we first need to convert the grams of glucose and the milliliters of water into moles. So let's have N1 be our water. This is equal to 460 milliliters. And next we're just doing some simple conversions. 1 milliliter of water, and this is where our density comes in. It's equal to 1 gram per mole times the molar mass of water equal to 1 mole. These cancel out and the milliliters cancel out, and all we're left with is 25.5 moles of water. Next, we need to find the moles of glucose, which is our N2. So we have 218 grams of glucose, and we are going to try to convert this into moles. We're given the molar mass in the problem as 180.2 grams per mole, equal to 1 mole. These cancel out, and we are left with 1.21 moles of glucose. Now that we have our moles, we can go ahead and plug this into our mole fraction to find the mole fraction of water. So we have X1 equal to N1, which is 25.5 moles, over the sum of N1 and N2, which is 25.5 moles plus 1.21 moles. When you plug this into the calculator, we get 0.955, and this is our molar fraction of water. Now that we have our X, we can go ahead and plug this number into Rayleigh's law to solve for our vapor pressure. So P1 is going to be equal to our 0.955 times the vapor pressure of pure water, which is 31.82 millimeters of mercury. And this gives us 30.4 millimeters of mercury. This lets us know that when 218 grams of glucose is dissolved in 460 milliliters of water, the vapor pressure is equal to 30.4 millimeters per mercury. But the problem also asks us to find the vapor pressure lowering. Vapor pressure lowering could be expressed as delta P, and to find that, we simply take the vapor pressure of pure water, which is 31.82 millimeters per mercury, and subtract the milliliters of water that has glucose dissolved in it, which is 30.4 millimeters of mercury. And when we plug this into the calculator, we have 1.4 millimeters of mercury. And this is basically telling us that when 218 grams of glucose is dissolved in 460 milliliters of water, the vapor pressure is lowered by 1.4 millimeters of mercury.